Okay, hello profs. My name is Yurang and I'll be presenting on behalf of my group for a 2D DDW component. So overview about the problem. Basically, Singapore land is very limited and vegetable is mostly come from imports overseas. Hence, vegetable prices in Singapore are very volatile based on external factors from these other countries. Our target audience are vegetable lovers who are concerned about the rising prices of the vegetables they consume and purchase. And our aim of our project is to be able to predict rising prices of imported vegetables such that we know when we can go with reduce our reliance on imported vegetables. Hence, in this project, we are interested in finding out how might we predict price of imported vegetables for Singapore based on external factors. So data set based on our problem statement, we have going to create a model that based on a set of external factors, and these factors are PSI, fuel cost, unemployment rate, and global temperature anomalies. So PSI is actually a measure of political stability of a country. We predict that the country with a higher PSI will indicate that supply and demand within the country is stable, leading to lower prices of vegetables. For fuel costs, this is directly related to the cost required for transport. Hence, higher fuel cost results in higher price. Unemployment rate we assume to be an indicator of the health status of the workforce in the country. Should there be a high unemployment rate, it will indicate that there's an implication in the supply of the goods, leading to a higher price. Lastly, it's also known that rising global temperatures are a driving force in the increase in frequency of extreme weather events, which are detrimental for our agriculture. So we use these to predict that there will be a positive correlation between rising global temperatures and price of imported vegetables. With this in mind, we researched data on government sites and identified that actually there are five main contributors to Singapore's vegetable imports, which are China, Australia, Malaysia, United States, and Indonesia. And we get a data based on these five different countries. This is just the links. Okay, move on to PSI. So here you can see the data for PSI. It ranges from 1989 to 2021. It has some missing values, but no worries. We'll settle that later. Fuel costs as shown ranging 1989 to 2021 as well. Unemployment rate same, GTA same, and price of imported vegetables. Basically, we process some of the data we found online and managed to get for 08 to 2020 data on the price of imported vegetables from each country. Data cleaning, we observed that there is insufficient data for years before 2008, hence we will only be taking data from 2008 to 2020. And as shown, we are just filtering out the ones that we want with the ranges. Yep, nothing too special. And then subsequently, we consolidated the data frame based on country. So here AUS has all the different dependent variables and independent variables. This is data frame. Subsequently plot the external factors with against the years to just to get understanding of how the data is varying over the years. So we did that for all five countries to better understand our data, to know what we're working with. So features and target preparation, as mentioned, I already explained why we used the four different features. And here we are plotting the dependent variable against the features to roughly get a sense of how the data varies and try to get a better understanding of that data. And we did that for all five countries again. Yep, nothing too special. So building our model, for our model we'll be using multiple linear regression. This is all just code to figure out the math behind it and calculate the values accordingly. We combine all the data sets into one big data frame and subsequently perform the model. So here you can see the features are the four external factors as mentioned, and target is price of imported vegetables. So you split the data set into the training and test data set. We did this with a test size of 0.1. So ensure sufficient data used to be trained to the model. The rest is just multiple linear regression. We did 2000 iterations to ensure accuracy. And 0.05 of our value indicates 95% strength accuracy in our model. Yep, so we only just calculates everything. That gives us an output of predicted values. Okay, for evaluation matrix, we use root mean square error and adjusted R square. Brief description, MSE is basically the average square difference between the estimated values and the actual value. Closer this value is to 0, the more accurate our model is. RMSE is basically just the root of that. Coefficient of determination is a coefficient that explains the variance of one variable to another variable. So if it's close to 1, it means it's good. Close to 0 means it's bad. And it's a good measure of the performance of the regression models and it's widely used. However, the limitation is that if there are too many independent variables, the model will overfit and the test data will perform poorly even with a high R-square value. Adjusted R-square value corrects this overestimation by including the number of independent variables. And hence to evaluate a model, we'll be using RMSE and adjusted R-square. So this is just the math again, to code the code behind the math. And then this evaluation. So we plot target against predicted values against actual values to get understanding. And then we can see that the RMSE value calculated is 39, which is pretty decent compared to our data. And adjusted R-square comes up to 0.58, indicating a decent correlation between our independent variables and the dependent variable. So improving the model, our group adopted the linear regression. So we realized that if we analyze the individual independent variables and how they correlate to the dependent variable, we'll be able to identify which has a higher correlation as compared to the others. And we did basically single linear regression for each of the individual independent variables. So as you can see, for field cost, the adjusted R-square is 0.399, indicating a good correlation. For the PSI, actually is close to 0, which makes it indicate that there's little to no correlation. Unemployment rate 0.33, decent correlation, and GTA negative value and R-square value is actually close to 0, indicating no correlation. So we identify that the GTA and PSI is basically useless, so we removed it from our model and perform the whole model again with just these two values, these two independent variables, and the output is actually a better model. Our R-square value increased and our RMSE decreased, indicating an increase in performance for our model. So discussion analysis, basically we analyzed that the results that we got based on our evaluation metrics is really good, and our model actually works in predicting the price of imported vegetables with ample accuracy. Thank you so much.